going to pick it back up with number 5, and I showed this in the previous video, but I'm going to show it again here today in this class. And that is some notes that we took yesterday in Algebra 2. If I can get there. And it's this right here, using properties of logarithms. And it's particularly this one here on the left where it says if I've got, let's say b, and I have a log as an exponent where the base of that exponent is b, and then the number of that log is x, then the answer will be the number of the log. It'll be x. Everything else will end up canceling out, and you'll be left with x. Right? And so they give you another example down here of 2 to the log base 2p. Now, these two numbers have to be the same in order for it to work. Okay, so if those numbers are the same, we're golden. Okay? All right, so let's go back to where we're at here. And it's really hard to read, so I'm going to write it out a little bit bigger. This says 2 log base 2, which is good for us, radical 7 plus log base 2 radical 10. Now, you'll notice that my 2 is out front and everything is in base 2 as my exponent. What I'm actually left with is radical 7 times radical 10, because I'm going to multiply those things as I drop off those logs which have the same base. And radical 7 times radical 10 is radical 70. Because that won't reduce any further. 7's already prime. 10 is made up of 2 and 5. I don't have anything that duplicates more than once. Does that make sense? So I get radical 70 as an answer for number 5. Right? So once I know that that's how it works, and I see the plus in question number 6, it's 4 to the log base 4 radical 3 plus log base 4 radical 5. Right? I think that's all right. I should just be able to say, oh yeah, well that's going to be radical 15.
Yes.
Yes? Yeah. Okay. And radical 15 won't reduce because that's 3 and 5. I don't have 2 of anything there, so I'm just stuck with radical 15. So are we pretty good there? Great. All right. So 5 and 6 are way easier than they look. And this is stuff where, if you saw this on like an ACT question, it goes from being like, oh man, I have no idea where to even start. Let's just fill this in and move on to, holy cow, this, not only is this, do I know how to do this, but it's also not going to take me any time, right? So that's, you might get one question like that on an ACT that, can bump things up a little bit further. Number 7, this is where we switch things over to lesson 60. Okay, factorable trigonomic equations, loss of solutions caused by division. So what you see here in 5, this is factorable trigonomic equations, or not 5, 7 and 8 are factorable trigonomic equations. So hopefully I've got a good set of notes here. We can at least cover one of these, possibly. Okay, so I'm going to switch this over. You guys have this page, right?
Yeah.
Yes? Okay. So I'm going to move over here, and I'm going to write it out. All right, so what they tell me is 4 sine squared theta minus 1 equals 0. Right, and we've seen a lot of stuff like this, right, where we're trying to find a range of values inside of this. All right, let's go to my notes over here on number 7. The way I write this off at the beginning is 4x squared minus 1. Okay, and 4x squared minus 1, whether or not it looks like it or not, is a sum difference factorable equation, right, that will come down to 2x minus 1, 2x plus 1, okay? And we would set each of those equal to 0. So what you have to keep in mind is that x is representing sine here. So what we're saying is 2 sine minus 1 equals 0, right? And we'll start from there, okay? All right, so if I'm going to try to solve this, I'm going to add 1 and divide by 2, correct? So sine theta equals positive 1/2, correct? Sine theta. We're going to try to figure out what theta equals, so we're going to come over here. Sine is opposite over hypotenuse. So we got 1, 2, radical 3. That would make this 30 degrees, correct? And I could also find this over here, right? Where this is 30 degrees. All right, so we need to find the true degrees there. This is 30, and this is what? 150. 150. So we have 30 and 150. Okay. Let's see if they give me any others there. Okay. Let's see. But here's because it's already just theta, right, I can't go around again. I'm going to be greater than 360. So the other thing I need to do is I need to check our 2 sine theta plus 1 equals 0. So I'm going to end up subtracting 1, and so I'm going to get sine theta equals negative 1/2. Okay? Okay, so negative 1/2 should bring me down below, right? To these two, right? So this is still 30 and 30, right? Which means this one's going to be, what, 210? And this one's going to be, what, 330? Okay? All right. So it looks like I have 30, I have 150, I've got 330, I've got 210. And I'm thinking, let's see, let's go back and look at how the question is set up. That on number 4, it wanted it in degrees. We have our answer in degrees. One of the crazy things that, like, if you look through on how, like, the book will solve this question or how something else, actually convert everything over to radians and then back into degrees. And that drives me crazy because it ends up adding a whole bunch of steps that aren't necessary for solving this that end up taking, a whole big chunk of my paper. I'm like, wait a second, that's redundant to do that. So, yeah, I don't know why it did that, but you kind of live and learn the longer that you're in this. All right, do you think we might be able to do number 8? Okay, let's try number 8. All right, number 8. Let's see, 4 cosine theta squared minus 3. Minus 3 equals 0 on 8. Okay, here it is. All right, so what I ended up doing with this one, because this isn't automatically factorable, right? Because if you look at it, it's 4x squared minus 3 equals 0. What I ended up doing with this is I added 3 to the other side so that I had 4x squared equals 3. Okay, then I divided by 4, right? So I had x squared equals 3/4. And then what do you do to solve for x in that case? Square root. And because I'm square rooting the left-hand side, on the right-hand side it's going to be plus or minus, right? Okay, but as I look at this, okay, so I've got x equals positive or negative square root of 3 over what, though? Because square root of 4 is going to come out, right? 2. So I got positive or negative square root of 3 over 2. And this was cosine, right? So, I can swap out my x and say, well, this is cosine, right? And I should wind up with 4 positions for my negative radical 3. Let's see, cosine being at adjacent, so radical 3, negative radical 3. So this would end up being 1 and 2, 2. So these would all be 30s, right? Yeah. So what I'll end up getting is just what I got in the last question, right? 30, 150, 210, and 330, right? It ends up in the same places. Does that make sense? Okay. So I'll write these up just for posterity's sake. 30, 150, 210, 330 degrees. And if you guys are looking at that page, does this want my answer in degrees or radians? Wants it in degrees, so we're going to leave it in degrees. So we end up getting A for an answer right there. What I'm going to do is I'm going to pick up with question, let's see how far, 9 and 10. I'll pick up with questions 9 and 10 tomorrow, but I'll go over it with the other class and I'll go over it with you guys. All right, just to make sure that there's no confusion on that, okay? All right.